There is another world aside from the world of what we can see. This is not really an invisible world or a spiritual world. It is a world that only those with a magic wand called the microscope can see. This world is the microscopic world. Okay, let's be serious now. What is microscopy? Microscopy is the technical field of using microscopes to view samples and objects that cannot be seen with the unaided eye. To use the microscope efficiently and with minimal frustration, you should understand the basic principles of microscopy, which are magnification, resolution, numerical aperture, illumination, and focusing. I will explain these principles in subsequent videos. For this video, I'll help you to understand the types of microscope we have based on certain criteria and also damage some misconceptions we have about some microscopes. So don't forget to subscribe so as not to miss out on awesome stuffs we have for you. For our subscribers on Biology Made Simple, Biopurpose Mobile Institute is the first channel that led to the creation of Biology Made Simple online class. For several months, Biopurpose Mobile Institute has been on a mission to revolutionize the way biology is being taught in high schools by conducting practicals and experiments in order to rekindle the passion in students to learn for a purpose. Watch more of our videos of biology experiments and practicals on this channel. Back to our topic. Let's look at the types of microscopes we have based on the following criteria: complexity, number of ocular or eyepiece lens, light, and beams. You must also know that some microscopes are a combination of some of these criteria. Based on complexity, we have two types of microscope: the simple microscope and the compound microscope. The simple microscope includes the hand lens, or what is presently called the reading or magnifying glass. The difference between the simple microscope and the compound microscope is the fact that the compound microscope has a high magnifying and resolving power compared to the simple microscope. This contributes to the bigger size and complex structures of the compound microscope. Based on number of ocular or eyepiece lenses, we have two types of microscope: the monocular compound microscope and the binocular compound microscope. Most binocular compound microscope has an oil immersion objective lens of 100 times magnification. Based on usage of lights and beams, we have two types of microscope: the light microscope and the electron microscope. I would like to use this opportunity to damage a misconception some students have about the microscope. Some light microscopes use light rays that comes from an electric power supply, and many students are inclined to call it an electron microscope because it uses electricity. This is one hell of a misconception. The light microscopes are further subdivided into two types based on number of ocular or eyepiece lenses, which I just explained. So you should describe them as the binocular compound light microscope and the monocular compound light microscope. Now you also have to know that the binocular and monocular compound microscopes come in various sizes and body designs, which does not really affect the overall function of the microscope. Light microscopes uses visible light to see tiny organisms that are mostly 1 to few cells thick, like onion cells and chick cells. The light microscopes does this by passing light rays through the cells. Electron microscopes are further subdivided into two types, based on the way the electrons act on specimen: scanning electron microscope and transmission electron microscope. These microscopes views the ultrastructure of tiny organisms by striking electron beams on them. Scanning electron microscope depends on the emission of secondary electrons from the surface of a specimen. It provides detailed images of the surfaces of cells and whole organisms that are not possible by transmission electron microscope. It can also be used for particle counting and size determination, and for process control. It is termed a scanning electron microscope because the image is formed by scanning a focused electron beam onto the surface of the specimen in a raster pattern. The transmission electron microscope is used to view thin specimens like tissue sections, molecules, etc., through which electrons can pass, thereby generating a projection image. The transmission electron microscope is analogous in many ways to the conventional compound light microscope. Transmission electron microscope is used, among other things, to image the interior of cells in thin sections, the structure of protein molecules, the organization of molecules in viruses, and cytoskeletal filaments. Electron microscopes are very expensive, so it is commonly used in research laboratories, universities, and nanotechnology centers. In these institutions, the structure of the specimen can be observed in great detail to provide information about its functions. Okay, we've come to the end of the first part of this introduction to microscopy. I will explain the parts of a microscope and their function in the next video. Please do well to subscribe to this particular channel so as not to miss the next video. See you in the next video.